Okay, we're trying to find the surface area. It's going to turn out that for this function, our surface area corresponding to the region r from 0 to a, theta from 0 to 2 pi of this vector function is going to describe the upper half of a sphere of radius a lying above the xy plane centered at the origin. That surface area should be this integral. So the integral that we want to perform is the integral of the magnitude of r sub r cross r sub theta dr d theta, and now we're going to be able to put limits in the integral. R is going to go from 0 to a, theta is going to go from 0 to 2 pi. Now we've calculated our magnitude of r sub r cross r sub theta, found that it's little ra over the square root of a squared minus r squared. I certainly hope that's right, but let's integrate and find out if this works. So we have integral from 0 to 2 pi, integral from 0 to a of ra over a squared minus r squared. That's little ra over the square root of a squared minus little r squared dr d theta. The integration is straightforward enough. The integral with respect to r, we're going to let u equal a squared minus r squared, so that du equals negative 2r dr, so that the r dr we do have here is negative du over 2. Our double integral therefore becomes, and I'm going to factor this a out, so we have a times the integral from 0 to 2 pi of the integral from r equals 0 to r equals a of 1 divided by the square root of u multiplied by dr, which is negative du over 2. And I said something about a natural log, and just ignore that. A quick side comment without much thought. This is a square root, not a reciprocal of a first power. So, adjusting our constants, our antiderivative is going to be 2 times the square root of u, and that's very straightforward. That will bring the negative 1/2 out here, so I'm going to have a negative a over 2 times the integral from 0 to 2 pi of and we'll write this as 2 times the square root of u evaluated between r equals 0 and r equals a, and then all that integrated with respect to theta. Now u is square root of a squared minus r squared, so that's negative a over 2 times the integral from 0 to 2 pi of 2 times the square root of a squared minus r squared, evaluated r equals a, and r equals 0 with respect to theta. When r equals a, this is 0. When r equals 0, this is 2a. So this expression here just reduces to 2a. So we have now the integral of negative a over 2 times the integral from 0 to 2 pi of 2a d theta. Well, the 2a and the negative a over 2 give us an a squared. And I do have an error. I said it a little too quickly. The r equals 0 is the lower limit, so we're going to be subtracting the 2a, so this should be negative 2a. And now, when we multiply this out, we get a squared. That's times the integral from 0 to 2 pi of d theta, which is 2 pi a squared. Now recall that what we started with was a hemisphere of radius A. So hemisphere radius A has surface area, should have surface area 1/2 times 4 pi a squared. Surface area of an entire sphere being 4 pi a, entire sphere of radius A being 4 pi a squared. Half of that is 2 pi a squared. So this is okay. So, in the case, at least of this function, we've justified this formula for the surface area.